We hope to get away from that with various methods of gaining confidence in the materials and adding some health management or health monitoring systems to them. But we have looked at these for quite some time. I think this is actually, someone mentioned dinosaur. This is actually a dinosaur structure there, I believe, in our laboratory, a metallic structure, undergoing some thermal evaluation there, and various other systems that make use of these high-temperature composite materials. Very, very effective for providing the durability that we need, and very strong. Some of these materials actually increase in their strength at the elevated temperatures, which is pretty interesting. Something like this needs to do some maneuvering in its terminal maneuvering after it's been heating for maybe an hour in flight. You're not going to do that with an aluminum structure that's going to become somewhat soft after it's flown for extended periods of time. So very effective for certain applications. Next, please. So in summary, the Department of Defense and the Air Force needs low-cost, on-demand space access for putting various assets into orbit that might be damaged or destroyed in a wartime scenario, or passing other components quickly across the globe. Near-term solution that we're looking at is a hybrid launch vehicle, one that uses a reusable first stage and then an expendable second stage. But we need some advanced structural concepts to enable that to become a reality. And indeed, the Air Force Research Laboratory is leading the development of quite a few concepts that are going to take us a long way to achieving that responsive space access. And we have some concepts for the leading edges, durable TPS, warm structures, and hot structures. And with that, any questions? Yes, sir.
Now, what was the carbon-carbon thing?
What was it?
What's carbon-carbon composite?
Carbon-carbon is, it uses carbon fibers and a carbon matrix. You'll have carbon epoxy in your sports equipment and such, where the epoxy just can't handle the very high temperatures. But carbon can go very high in temperature. The problem is oxidation and such, so we look to protect it from that. But with a carbon matrix and a carbon fiber, it can handle extreme temperatures when there's no oxygen present. It's what the leading edge of the space shuttle is made of.
Charcoal and carbon fiber.
It's essentially, yeah, they're all just different forms, but yes.
I was wondering, how big are these vehicles?
Well, I can't say that we have any definite designs at this point, but looking at some scenarios, only maybe 5,000 pounds to orbit, others 15,000, not usually well above that.
Delta II class? Without strap-ons?
Yeah, I guess I couldn't say there. It's you saw some images earlier that kind of give you, I guess not really a size, but a configuration. But yeah, certainly a whole lot smaller than a space shuttle. Maybe.
Say compared to an F-16.
A bit bigger than that. Probably a bit larger than that. I'm not actually in the vehicle design so much, so I don't know the exact actual lengths. Don't recall them at this point.
I thought I heard you say back in the beginning these are all unmanned systems.
We're looking at unmanned systems, yes.
How does the Air Force feel about this? The maneuverability or the on board? Or what are you going to do with these systems then if they're unmanned?
Well, they'd be like Global Hawk or Predator. They're either control themselves, or you have a guy flying a stick from the ground. So. Not necessarily military. It could be a satellite launch and such. The Russian shuttle went up and down without any crew. Isn't that correct? That was unmanned.
They had a full re-entry and runway landing with Buran on its one test flight.
Yes?
How do you get by without an orbital maneuvering system? What does a deep orbit operation, for example?
I'm sorry. What that was indicating was the reusable booster. The booster does not hit orbit. It would go up 200,000 feet. Launch the expendable system that would go to orbit. So for that hybrid system, it doesn't need the maneuvering system up there and to deorbit as such. Yes.
You mentioned that they're looking at composites for hot structures. I was wondering, is there any active research into composites for cryogenic tanks? Or?
Oh, absolutely. That's a very key aspect is the cryogenic tank, and that in a lot of our concepts, the tank is the structure. And we're looking at various methods of improving upon that, using methane instead of hydrogen, and that it's closer in temperature to the oxygen. Reduces the amount of insulation you need between various components. We're looking at tanks that have a single wall on the inside rather than separate tanks. Cryogenic tanks is a very key part of our research.
That's about all we have time for.
All right. Well, thank you very much.